Assalamu alaikum kids. In the previous video we discussed distance time graphs, and inshallah in this video we will discuss velocity time graphs. So the types of motion that we discussed or defined in distance time graph were very limited. We are going to define some more types of motion for velocity time graph because we have more information. Number one is stationary object, of course. Number two, object moving with constant velocity, increasing speed and constant acceleration, increasing speed, increasing acceleration, increasing speed, decreasing acceleration, decreasing speed, constant acceleration, decreasing speed, increasing deceleration, and decreasing speed, decreasing deceleration. So we've got at least 3 to 4 extra type of motions that we are going to define using a velocity time graph. So for a stationary object, the velocity time graph is a straight horizontal line passing through the origin. Now it's very important to remember that only a horizontal line passing through the origin for a velocity time graph will represent an object at rest. For an object with constant velocity, your graph is a straight line, but it should not be passing through the origin. A straight horizontal line not passing through the origin. An important thing to remember is that the gradient of a velocity speed time graph is acceleration. So this right here is what the graph would look like. You'll have horizontal lines which will not be passing through the origin. So again, the origin is down here. You've got straight horizontal lines which are not passing through the origin. Now, as we discussed that the gradient is the acceleration, now what's the gradient of a horizontal line? The gradient of a horizontal line is 0. And because the gradient of a horizontal line is 0, your acceleration must also be 0. Alrighty? Now, we need to define acceleration. Previously, in the previous video, we said that distance time graph cannot be used to define acceleration, but here, your gradient is the acceleration. Hence, velocity time graphs can be used to define acceleration. So, the first is constant acceleration. Now, object moving with increasing velocity but constant acceleration means that your gradient has to be constant. And when we say that our gradient has to be a constant, it essentially represents a straight diagonal line. Now, the diagonal line may pass through the origin, may not pass through the origin as shown on the diagram. On the diagram, we have object 1, object 2, and object 3. Well, object 1 is not passing through the origin. That means that the acceleration started when the object was still moving. For object 2 and 3, the acceleration starts when the object was at rest. Over here, the velocity is 0, means object 2 and 3 were initially at rest and then they started accelerating. But object 1 was not stationary. It already had a certain amount of velocity, hence it was already moving when we started accelerating object 1. So comparing the acceleration of objects 1, 2 and 3, because a higher gradient means your object is accelerating much harder, hence object 1 is accelerating more than object 2. The acceleration of object 1 is more than object 2, and the acceleration of object 2 must be more than object 3. For an object with increasing acceleration, the graph must have an increasing gradient. So the graph would look something like this. It's going to be curving upwards. So let's say, for example, you have this point A right here with a gradient 3, and you have this point B right here with gradient 5. It's obvious that B would be accelerating much harder than A. Why? Because it has a greater gradient. For an object with decreasing acceleration, acceleration is the gradient of the graph, hence decreasing acceleration means decreasing gradient. So your graph is going to look something like this. It's going to be a curve downwards, where you have point A, so let's name this A right here. And you have point B, let's name this B right here. As we can see that the gradient of A is larger than gradient of B, hence A is accelerating harder than B. Now, for an object with constant deceleration, we need to understand that the object is moving with decreasing velocity. Well, gradient is acceleration, hence constant gradient or constant acceleration must be constant gradient. But there is one very important thing to remember, that for an object with decreasing velocity, gradient is negative, hence the graph must be pointed downwards. So something along these lines. All right. This right here would be graph of an object with decreasing velocity and constant deceleration. Let's talk about increasing deceleration. For an object with increasing deceleration, the magnitude of the gradient must also increase. Now, at this point, you need to understand a couple of things. Number one, deceleration means that your gradient is negative. And number two, deceleration means that your velocity is decreasing. So your graph is going to look something like this. It's going to curve downwards. But this time around, at point A, you have the gradient minus 2. And at point B, you have the gradient minus 5. Now, comparing the two, mathematically, minus 5 is smaller than minus 2. But like I said, we are only mentioning the magnitude. So the magnitude of minus 5 is much more than the magnitude of minus 2. Hence, your deceleration is increasing. On the other hand, we have decreasing deceleration, keeping in mind that while decelerating, your velocity is decreasing, means your graph must be pointed downwards. Second, because you have deceleration means the gradient must be negative, the magnitude of the gradient for a graph with decreasing deceleration must also decrease. So the graph would look something like this. Now let's take a couple of points. Point A with gradient minus 5 and point B with gradient minus 2. Now we can see on the graph that A, the gradient is minus 5. The magnitude is higher than gradient at B, which is minus 2. Minus 5 has a higher magnitude than minus 2. Mathematically, minus 5 is a smaller value than minus 2, but the magnitude for A is higher. The number itself is higher for gradient at A. Hence, A would be decelerating harder or braking harder than B. It's very important to be able to show the change in direction on a velocity time graph. So let's say, for example, you have a line going something like this. Over here, throughout this part right here, where your velocity is positive, your object must be moving in the forward direction. Where your graph crosses the x-axis is where the change in direction occurs. So this right here is where the change in direction occurs. And then over here, right here, throughout this part, your object must be traveling backwards. So a positive velocity means that your object is moving forwards, and a negative velocity means that your object must be moving backwards. Let's take a look at another graph right here. In this case, your object was initially moving backwards, then it changed direction over here, and then it started moving forwards.